Hello, good morning. My name is Lauren. My name is Lauren Poe. Hi, Tegan. I'm a developer at ESPN. I'm really excited to introduce Tegan Bunsu Ashby. She's a senior software developer with the Brooklyn Nets.
Sorry. No.
Great. She works at the intersection of data and design, building applications and visualizations to empower basketball decision-making and help win games. Before joining the Nets in 2021, she spent 3 seasons with the Philadelphia 76ers in research and development. She is also the co-founder of Women in Sports Data, an initiative to amplify women's voices in sports analytics across the technical spectrum. She holds degrees in linguistics and Near Eastern languages and civilizations from the University of Pennsylvania, where she studied symbolic systems, formal syntax, ancient Mesopotamian languages, and the world's oldest spreadsheets. Enjoy.
Let me make sure this is on. Thank you so much for the wonderful introduction, and thank you to the organizers for inviting me here this morning. I really want to give Lauren a particular special shout out because you were so gracious enough to participate on a panel on this very topic at the conference that I organized back in August, the inaugural Women in Sports Data Symposium in Brooklyn. And I also want to thank Junyan for chairing this event and making this full day happen. Thank you. This is such an incredible program, and it's an honor really to be part of it this year. So let me give you a little extra background on me. As Lauren said, I am a senior with the Nets front office, and this is my second full season with the Nets after spending many years running the lives of the greater Philadelphia region with the 76ers. I work with a team of other brilliant engineers, data scientists, and analysts to provide insights to the organization to empower basketball decision-making. So yes, I studied formal linguistics and dead languages at the University of Pennsylvania, symbolic systems because cuneiform looks like chicken scratch. I studied things like complex state machines and the theories underpinning the models of computer and human languages. But yeah, cuneiform, like Sumerian and Akkadian. And I would argue that this is honestly the most valuable thing that I could have learned in school because working with dead languages, particularly Sumerian, has influenced a lot about how I think about solving hard problems. And it also helped me to develop a lot of technical, practical, and creative skills that have been invaluable to my work in basketball. Cuneiform tablets are like the OG databases, and you learn a lot about data persistence and corruption when your source material is 4,000 years old and it literally comes out of the ground in southern Iraq. So I learned Bash and Vim not only in my computer science and linguistics classes, but by tagging Sumerian morphemes for the electronic Pennsylvania Sumerian Dictionary project. I learned about applied statistics by working with the many economic texts from the Ur III period, which is a span of about 100 years between the 22nd and 21st centuries BCE. It's the most documented historical period up until the Industrial Revolution. And I learned a lot of really weird, hard math with a base 60 sexagesimal number system when I was translating a Neo-Babylonian astronomical text from the 8th century BCE. But I guess possibly the most underrated skill about learning how to read cuneiform, and I guess you can be the judge of this after this talk, was how do you distill a lot of arcane, complex knowledge into a format that's accessible to a lay audience? Esoteric stuff like NBA defense. But today we're going to talk about my other favorite soapbox, which is software engineering in sports analytics, because I am a software engineer in sports analytics, and I just really love my job. What does that even mean, like software engineering for sports analytics? It's kind of broad, right? So before we get started, let's back up for a second and do some scene setting. Analytics, in part, is about mitigating biases. And yet, when I say sports analytics, what I really mean is basketball analytics, because I work in basketball. I've only ever worked in basketball, and because ball is life. So in true engineer form, we're already going to cut down the scope of requirements here for this project. I'm going to do my best to give context for other sports where I know it or where it's appropriate. But a pretty good rule of thumb for today is that when I talk about sports analytics, unless otherwise specified, I'm probably talking hoops. But also sidebar, as a member of a front office, it's actually kind of difficult for me to speak with any real specificity about what I do beyond what's publicly available or in a job description because of how much teams prize a competitive advantage. And even though this industry is growing, they unfortunately do not pay me enough currently to afford a tampering fine. So we can be really extra about this sort of thing in the NBA. The Brooklyn Nets front office is actually one of the few teams that doesn't even list our personnel on our NBA team website. And I've heard that even some teams can be so tight-lipped about their technical stack, like, ooh, we use React on our front end and a Django back end, so innovative. But literally everything is a competitive advantage. And we can be very clandestine, keep it secret, keep it safe. So maybe this is a cop-out, but if this talk was called Mildly Spicy Takes, tangentially related to coding for pretty much only, but yeah, whatever, basketball analytics, I would have been disinvited. So we're going to go with software engineering for sports analytics. Let's look at Twitter. Here's a tweet that I wrote a couple months ago, in part to promote the software engineering panel at Women in Sports Data. Hey, Lauren. Practically half the NBA was looking to hire a software developer or a data engineer last year. If there's an open position with an analytics group for any sport, I bet you it's for an engineer. Be a dev. Okay. Which brings us to our theme today. Hiring for engineers and developers is booming in sports, but what exactly do they do for a professional team? I mean, we're not analysts, we're not scouts, we're not coaches. You don't want to see my jumper. What are we even doing here? Students often ask what my day-to-day looks like working for an NBA team, and I have to admit, I struggle to answer this in a compelling way because the answer is, I code. But also my front office role heavily impacts what that code actually executes, and that's secret. So there's not really such a thing as a typical day, since the work follows the cadence of the NBA calendar, and I'm usually working on a long-term project and several one-off requests. And depending on the time of the year, I'll be working on projects and products related to coaching, the front office, scouting, sports science, etc. But every team is different. Every front office is different. I've been a part of essentially 3, and I think it's really hard to tell what actually goes on inside of any given front office or quote unquote analytics department. But that's effectively the question that we're going to try and answer today. What are we even doing? So here's the roadmap. I'll start with the evolution of data sources in the NBA as a model of how the statistical revolution in sports analytics has affected how the game is played. Then I'll highlight some of the technical skills in demand for software engineers in sports analytics, including cloud services, big data stream processing, statistical modeling, data visualization, design, by looking at a couple candidate profiles from job ad descriptions. I'm going to talk about some of the core responsibilities for building out infrastructure and applications for an audience of data scientists and decision makers on and off the court. And then we're going to look at a case study of the ubiquitous, love them or hate them, hex spin shot chart in NBA basketball, where they succeed and where they fall short, and talk about how data visualization and communication are an essential part of an R&D or analytics department's workflow and output, and how software developers can empower both their analysts and their stakeholders to make winning decisions. We'll then touch on how the technical demands of the current data landscape has shaped the discourse of sports analytics and give some hot takes on the ideal function of a so-called analytics department. So, despite being a card-carrying member of the Church of the Denver Broncos, I know. This is where the caveat applies of when I'm saying sports, what I really mean is basketball. I'm really unqualified to speak about the statistical revolutions in other sports, given that I do not know how they work. But if you want to know more about data and data sources, for instance, in the NFL, or maybe the theme for next year's Big Data Bowl, stay tuned for the schedule coming ahead, which is packed with far wiser data nerds than me. But I hope I at least have basketball covered for you. So to begin, I think it's important that we talk at a very basic level about what data is and where data comes from, because those are our building blocks for everything that we do on the team side, from draft projections to player evaluation to rebound modeling. And that is what the software developer in various specialized roles is going to have to guard in. In the beginning, there was the box score. Well, for basketball, in the beginning, there was nothing but a peach basket. But eventually, we created the box score. But data is made up, and we decide what matters, what to count, and everything on top of that is human intervention, and that's a process and an abstraction. But basketball analytics is kind of new. Up until 1996, the best data that we had for describing what happens during a basketball game was the box score, which of course is still alive and well. And if you're looking at a Gamecast online, for example, you're probably looking at a box score. The box score consists of mainly counting stats. So the sort of stuff that you see, like how many points were scored? Was that basket for 2? Was it for 3? Was it a free throw? How many steals were there? How many rebounds? And it's generally about 30 rows of data per game for the full rosters of each team with over a dozen data columns. And because of this, it can be a bit limited. It captures only a fraction of what happens during a game because it's so heavily weighted towards offense. It's outcome driven, and it can obscure or underweight the magnitude of a player's defensive contribution. That all started to change in the 1996-1997 season in the NBA when play-by-play data became available. Play-by-play is sort of like color commentary. It's talking about events and players on both teams who are involved, like this player scored 2 points and it was a dunk with an assist. So we have temporal information that is retained. We start to get lineup data. We can approximate matchups. We also get X, Y location data for shots. And play-by-play is about 400 rows of data per game, and that also requires some amount of parsing. Then in the 2013-2014 season, we get player tracking data, which is now provided by a company called Second Spectrum, which takes the event data of what happens on the court, the X, Y, Z coordinates associated with the ball, events, and player actions using 2D cameras installed in every regulation game and in every NBA stadium. And then we're getting 25 frames per second sampled. So extrapolate those data tracking points per player over the course of a 48-minute game. And with downstream processing, you come out to around 1 million tracking points per game. So let's take the example of the pick and roll, the quintessential basketball action, where a teammate puts his body in front of the defender who's guarding the player who has the ball. This is the pick or the screen, so that the ball handler can move past the screen and either look to score or pass. And then the screener rolls to the basket and is open. This isn't captured at all in the box score. The play-by-play maybe captures some of the events, like the pass, if it's an assist. But player tracking data gives us nearly the full context of the play. And so what we're looking at here in this diagram comes from an article that Zach Lowe wrote for Grantland in 2013 about the NBA's adoption of the new player tracking camera system then done by a company called SportView. And specifically, he's talking about how the Toronto Raptors and my former director of R&D in Philadelphia, Alex Rucker, developed applications on top of this data. So here they're exploring a concept of what they call ghost players, doing what Toronto believed a player should have done on a given play. This one is from the Knicks Raptors game. The Knicks players, Carmelo Anthony, who's the blue number 7 jersey, and Tyser Chandler, who's jersey number 6, are running a pick and roll here on the left elbow, and Chandler is going to roll to the hoop. We can see that Mello is handling the ball on the right side of the floor. It's that really tiny circle on his jersey number. And so that makes the left side the weak side. And so Toronto's DeMar DeRozan, number 10, is supposed to be helping on the big man, i.e. Chandler, to prevent him rolling to the paint. So what we currently have in basketball is 2D tracking camera data. As I said, we're getting 25 frames per second of the XY coordinates of a player, and that includes the Z coordinates of the ball. But there's still a lot of data that we'd love to have for additional context. Basically, what I'm talking about is pose or skeletal key points, the ability to detect body, hand, and foot position over a series of frame. And this is probably the future of player tracking data. You can imagine how valuable this might be for evaluating a contest or a closeout or a player's shooting motion, and how this might enhance the in-game metrics for our performance staff, which I'm going to elaborate a little bit later. So skeletal tracking requires new depth cameras so that we can disambiguate overlapping limbs and handle the wild lighting conditions in arena. My favorite part of the game happens to be when there's fire behind the hoops, but I'm not really into the strobe lights. So these cameras would solve for that. There are also a couple of public systems that can use 2D cameras for pose detection, like CMU's OpenPose, but that will produce fewer frames of data. With fully fledged skeletal tracking, depending on the number of frames and the number of key points detected, we're going to generate, say, tenfold the amount of data that traditional location tracking does. Spooky. So up to this point, we've been talking exclusively about data captured in a game environment. And the NBA Players Association has this very strict rule about what kind of tracking and measurement that you can do for players in game. But in a practice environment, in your own training facility, you have access to a lot more resources and technology. So here's a couple of examples. A lot of teams in the NBA and NCAA use a program called NOAA, which measures shots taken from any point on a court and returns data on things like the arc of a shot or the depth, like how far back it is toward the basket and whether it goes to the left or the right of a basket. And this can be useful for giving feedback to players as they're in their shooting motion so they can adjust in real time. But it's also really useful for a department like mine, and you want to model like what shooting action creates the best shooter. So another data source comes from a company called Connexon, which makes wearable sensors. At last year's WNBA Commissioner's Cup, players from the Connecticut Sun and the Seattle Storm wore these tags in the waistbands of their shorts, and that measured data on sprints, jumps, velocity, position, which in combination with optical tracking from Hawkeye, very similar to the camera tracking that we have in the NBA, reportedly generated approximately 50 million data points per game. And so I wish I had put a picture of Bernie Sanders in the meme, because if anybody is listening out in the ether, I am once again asking for access to this data. And maybe for next year's Women in Sports Data Hackathon, just saying. So now that all the fancy stuff is out of the way, last but not least, you have all of the data generated and managed internally for a team. And I'm talking annotated trades or scouting reports. And this kind of data is massively important for an organization, in part because it's unique to how that organization is set up and what its priorities are and what its goals and values are. So like I said in the beginning, all data is made up because we're deciding what's important to measure. And because we have so much of it, now you need some people to manage all of that. So we have this soup of data, millions and millions of rows of data. Cue the computer folk. Context matters. A software engineer for a baseball team versus a basketball team versus a football team, et cetera, is all going to look different given the maturity of analytics in these fields and the size of a given department and the values of individual teams. So here's a chart from Jay Kuda on Twitter plotting the number of baseball operations analysts and data engineers against their team's payroll. Baseball has a reputation of having the most mature of analytics departments because, Moneyball, sabermetrics, like you have your movie. And you see that teams like the Tampa Bay Rays, the LA Dodgers, the New York Mets, and my Philadelphia Phillies, they all have fairly large analytics staffs of 25 to 30 people. I was recently talking to somebody who leads the baseball's technical staff, and he mentioned that he had 4 front-end engineers alone. You can probably guess what team he's not managing. But this is more than my entire development staff, which is probably on the larger end for the NBA. And a friend of mine quipped in basketball that you should probably just divide the staff number access ticks by 5 to get the distribution of analytics staffers in basketball. But yes, there's still many teams in baseball and basketball who have comparatively small staffs. Again, we're going to have far more knowledgeable people on the docket today, but in hockey, from this chart from Shayna Goldman for The Athletic, we can see about 20 to 30 people with engineer or developer in their title, between a couple of those people who are clustered on the same team and those whose teams have obscured their personnel's titles as just analyst. That's maybe an average of 1 engineer per team. Which to me implies that analysts or data scientists are actually doing a fair amount of data engineering. And as we talked about previously, that's a lot of data. That's a lot of data to manage. And just another hockey fun fact, when I worked for the Philadelphia 76ers, our ownership group actually had a portfolio that included the New Jersey Devils. And it was literally in my contract that I could be seconded to hockey projects. So I apologize for any damage that I may have done, but I'm a gritty fan. And I think this comment from Seth Walder from ESPN was really interesting. He's talking about the status of developers in the NFL from a thread on his survey on analytics staffers for teams. And he says, the most common gray area is developers. I exclude by default, but include if I'm told they are specifically and primarily part of the football analytics operation. And I think of the major men's professional sports, correct me if I'm wrong, NFL teams tend to have smaller analytics groups. But so I found this really interesting because I've always worked in basketball and I've always considered myself to be part of an analytics department. And so I asked if they're not part of the analytics department, then what else are they doing? And I think there's this kind of this conception that developers, because they are not analysts, are not doing analytics. And I think we're going to see that it's really difficult to disambiguate the practice of making recommendations with building out the infrastructure. So I want to talk a little bit about candidate profiles. There's clearly a pretty diverse environment a person with the title or responsibilities of software engineer can have in a team environment in professional sports. So here, we're going to go through a couple examples of some profiles of recent roles that have popped up. This is becoming like a real growth area in an industry that rarely opens up staffing capacity. And the popularity of the discipline, given the increasing complexity of data management, whether that's from tracking data or generated in-house, is clearly providing a value add. So I want to do a little experiment. I apologize to those who are online, but I want to read out basically these position summaries and kind of the technical skills that are involved. And I want you to raise your hand if this sounds like you or this sounds like something that you would want to do. So this candidate is a software engineer who will lead development of the internal tooling used by coaches, scouts, and the front office. You're going to act as an engineer as well as product manager to build beautiful and sophisticated applications that help to power basketball decision making. So raise your hands. Who wants to do that? I love it because that's literally my job description. So this person is a full stack developer. They have to write JavaScript because that's how the web works. And ideally, they will have a background in TypeScript and Python. You should have experience building and working with REST APIs, and that can be in Node or Django or Flask, or maybe you're going to get fancy and write a Go backend. And you should also have experience with a front-end framework, which I think most teams that I've talked to, they typically say React, but I like to do a little bit where I try to proselytize about Svelte, which we won't have to get into, but you can talk to me later about the gospel of Svelte. And you should also be experienced with SQL and relational databases. So for example, Postgres. And you should have GitHub. You should understand how to configure a Linux server. You should be able to do data visualization. It's a pretty great job. But here's another one. This particular engineer is going to be responsible for collecting and transforming data from various sources as well. And I also like to interject, these are all real. These are, I have lightly edited them, but this is a real job description. As well as preparing and distributing data for consumption by teams, developers, and analysts. They will collaborate with data scientists to maintain, enhance, and extend data infrastructure. They are an experienced data pipeline builder who excels at automating and optimizing data systems with cloud experience. Okay, who is that? Fewer. Some data engineers in the house. So this is kind of like the archetypical profile of when teams are looking for a data engineer. Like we want a gardener. And so this one I had to edit because they asked for scripting languages like Java and C#, which are not scripting languages, but Python is. And you're going to be building pipelines, and you're going to be it really is kind of like gardening, like a Zen rock garden, because you're moving things around and warehousing these data and using things like AWS, Google Cloud, Airflow, and you're going to have to work with Docker. I'm sorry. And this job ad, I think, is also very interesting. I've omitted it from the slide. But they're also requesting experience building visualization again with tools like D3 or Plotly, Dash, or ggplot. And they're also requesting experience with web application development, especially JavaScript and React. And so of the people who raised your hand for both, can you raise your hand once more? Well, it's not like a huge number. We've cut down the ranks. So this final profile is a software engineer who will research, design, and test cloud-based quantitative modeling at scale. They will collaborate with data scientists to define and manage model productionization and platform release plans. So if you had to guess, anyone, what is this person's title? You know, Python, it's highlighted maybe. Yeah, you're an ML engineer. But again, this person is also expected to do front-end development in addition to the model training. And if you look at the toolbox that teams are requesting, like this is all job ad descriptions are essentially a wish list, and you don't need to have every single skill that's listed. But like, let's think about the reality of the landscape of developer staff, engineering staff across specifically men's professional sports. And if you're on average the one person who's doing engineering, it's a pretty big toolbox. And there's this idea of overlap, of blurring of roles. And so I think that there's a chance for you to really grow, and there's certainly opportunity, but it is a pretty big job. So this introduces some problems. And to a certain point, to be a software engineer for a professional sports team is probably the furthest away from the core spirit of the sport. But in my opinion, the job is impossible to do well and to enjoy without developing a certain level of sports statistical fluency. For practically every other role in a basketball operations, particularly on the front office side, you can get better at your job by watching more basketball. And so for a software engineer, watching more basketball is both a feature and a bug, which is, I want to talk about shot charts for a minute. What does it take to build a shot chart? And look, however you may feel about shot charts, coaches love them, players love them, people love shot charts. If you've worked for a basketball team, you definitely have a shot chart. And making shot charts isn't actually computationally complex. You only need the location data from play-by-play, although the markings context from tracking data is super helpful and insightful when you're filtering and framing the narrative for your answer to a specific question. And so one of the most well-known disruptions to the NBA game is how the three-point shot took over. And there's a lot of nuance to this conversation because of tracking data and about the efficiency and how we value shots. But I just want to point out while we're here that the trend of percentage of three-point attempts among all field goal attempts has steadily gone up, especially at the point of introduction of player tracking data in 2013. And yet the rate at which teams actually make those shots hasn't dramatically changed in the past several years. Typically sits around 36%. So teams aren't necessarily getting better at making threes in the aggregate, they're getting better at attempting them. So shot charts do a bunch of stuff well, like engage and communicate, something dense simply, and a bunch of stuff that they don't do at all or they do poorly, and that's what we're going to talk about. And so we're going to end this conversation on shot charts through Viz in the following things. How do shot charts reflect the influence of analytics in the NBA game? How do shot charts lie or obscure? And how can you develop them and communicate them in a responsible way as a software developer, as a member of an analytics department, as a member of basketball operations? So this is a hex bin shot chart. I feel like you've probably seen something like this. To me, it's very emblematic of the basketball analytics movement. And this is how you read this chart. Shot frequency is encoded with size. So fewer shots from a location are smaller, and the more frequent somebody takes them, the larger they are. Shot efficiency is a value of a rate of success. That is encoded with color. So more missed shots are blue, more made shots are red, and hue indicates density. That red hex in the middle of the hoop is denoting high efficiency, which is basically evaluation of a field goal that takes into account a 2 versus a 3, as well as whether it's fouled. So this is a plot of shots taken in the league in 2013. And the trend of taking threes is already fairly healthy. We can see that around 49,000 shots were from three, accounting for approximately 24.3% of all shots. There's still a lot of blue, big hexagons in the mid-range. So let's fast forward to 2019, where 78,000 shots were from three, accounting for 35.9% of all shots. A jump in share of over 10, and we can readily see in the chart that there's just so much more white space at the perimeter dividing the area between 2 points and 3. So if a 3 is a step or two back from a long 2, then it certainly makes sense to take the more valuable shot as a step back. Well, maybe. And this trend is even more dramatic if you look at a chart on team level. In 2013, this team took a lot of bad mid-range shots, but in 2019, their shot selection was more densely concentrated from three and at the rim. And I want to be a little cautious here about associating this strictly with the strong current of three-point attempts. This shot profile is also influenced by coaching changes and changes in players and strategy, but we're all playing in the same league. And so shot charts display outcomes, not processes, but teams are playing different processes to achieve those outcomes. And the process for generating more looks from three has meant more spacing of players, more attacking the rim for defensive collapse, and passing out of defenses to try and take away both the rim and the three, i.e. try to force the low return mid-range shot. But in general, they tend to get overextended. So the ripple effect is that defenses have to abandon how closely they're defending the rim. So offensive efficiency has gone up over this time period, not only because teams are shooting more threes, but also because the shot percentage at the rim is also going up. So let's take a look at a couple applications of shot charts. This first example is of a player who completely changed his game in the course of 4 seasons to adapt to this prevailing trend of three. In the first year here, he took roughly 13 shots from three, and he didn't make very many of them. But gradually, he's taking fewer and fewer shots from mid-range and more from above the break. After 4 seasons, he's taken 512 shots from three, making them at 36.5%, essentially league average. But all threes aren't created equal for him. As this player develops his three-point shot, he's mostly successful from the corners. So here in year 4 at the bottom right, at the wing on the top right above the break for the corner, it looks like he takes a pretty high volume of shots, but he isn't making very many of them. This player in year 2 and 3 actually already has a pretty decent three-point percentage, but he is taking a bit more than half of what he does in year 4, and that translates to a lot fewer points. So if you're a coach and you're game planning for this player, you know that he has hot corners and that he's a willing shooter above the break, and so you might recommend that let it fly if he's above the break. Like, that's a shot that you can live with, and that's something that you can see through this visualization. Which brings us to this concept of where do shots come from when they're from three? And if you look at a lot of shot charts, you'll start to notice that, like that player, the corners tend to light up bright red. So much so that people talk about getting the good corner three. And it's one of the best shots that you can take because they're worth 3 points, and people tend to make them more often, almost 40% of the time. So there's 2 things going on here that you might ask. One, why don't you just always take a corner three if they're better? And 2, what is it about the corners that make them so good? And both of these things are kind of tied together. So let's just start with the volume. In 2019, of all the three-pointers taken, the majority of them were taken above the break where the corner line meets the arc, about 16,000 more shots. And why that happens is probably related in some way to why corner threes tend to go in more often. And so if you look at the simple geometry of the court, you see one thing right away. The corners are closer. Interestingly, for 3 seasons in the mid-90s, the distance to the basket was changed to be uniformly 20 feet all around as the current distance from the corners, and three-point attempt percentage jumped significantly. So yeah, the corners are closer, and this is actually the premise for the addition of the three-point line. The reasoning being that the further away a shot is, the harder it should be, so it should be rewarded with more points. But we don't just play basketball like it's the all-star game, three-point contest. There are going to be a lot of typically large people in between you and the shooter and making that shot. So how you get the ball matters quite a bit, and how defenses can cover you. And so these shots from the corner in general tend to be assisted, meaning you receive the pass. It's a catch and shoot situation rather than off the dribble where you have to create your shot and you're running with the ball to a space on the floor and then you're shooting. So how defenses can be set, how closely a defender can get to you in order to contest your shot, all of that factors in. So it is a question both of court geography and court context. So the three-point revolution has been the prevailing trend in the league for well over a decade now. And abandoning the mid-range and going for three has, at league level, been typically the most efficient way to win. And sometimes I think with three being inherently greater than two, got it, sometimes I think this argument is spun on its head, like it's reductive, like basketball analytics is only saying to do this. Some revolution. But I don't actually think that this is such a simple proposition because players have different skill sets and different things that they're good at. And really the best way to win is to maximize those abilities and to put that into the alchemy of making a great team. So players individually aren't averages. There are many paths to success. And all of these shot charts here are of different players who have above average efficiency and fairly diverse shot profiles on over 600 field goal attempts. And I'm typically using data from the 2019 season because it's the pre-bubble season. So you can see that two on the top right and one on the bottom left look like they still take a prodigious amount of mid-range shots, and they're still doing just great. I think I have just one center up here on the top left. This is kind of the prototypical big man shot chart. But if you remember the first story that I told you about the player who completely transformed his game, he was a center too. So traditionally, charts have corresponded to certain player positions or roles. But now the league has more creative use of positions, and this has turned more based into role-based strategy basketball. And it used to be that like the role of a shooter and a floor of a floor spacer, like our first example, that was usually the smallest guy. And then the role of an offensive rebounder was usually the biggest guy. And that's typically not a shooting guard. But now I wouldn't say that you could tell that from a shot chart. The shot charts aren't necessarily descriptive of a player's position. So you do need to be careful when making assumptions or inferences from a chart because they are purely descriptive. So shot charts are still outcome-based, not necessarily process-based. And of course, we would certainly be able to slice the data here and there in certain ways, like show me only shots that were contested or ones that came off a pick and roll. But ultimately, there's a lot of the story to these shots that isn't told and can't be told by this type of visualization. These two shot charts look kind of similar, almost like mirror images, at least if you're looking past the three-point line, but they're not telling the story of how the player got those shots. They can't. These look the same, like the same shots, but they're not. So shot charts can be deceptive. We don't know the speed in which he got the shot, or that he got that shot, how he got that shot, or the distance between him and his defender. And so I think that we always have to be really careful about when we look at shot charts to make sure that we're applying them in a responsible and correct way that doesn't mislead. Okay, so shots, what are they good for? And I would say my brief as a developer is pretty wide. I work on whatever contributes to winning games. So that might entail building applications to facilitate recommendations for the coaching staff, or making products for scouting and player evaluation, or designing salary cap tools for the rest of the front office. But the thing that I most enjoy doing, the thing that I'm most interested in, is creating work that communicates data in an accessible and actionable way. And as a developer, one of the things that I can build is interactive data visualizations. I really like to synthesize data sets and complex models that our data scientists produce into something both a computer and an assistant GM can parse. And so it's this intersection between working closely with data scientists and analysts on one side and the front office, coaches, scouts, players on the other, the stakeholders, to use business parlance, like in a way makes a software developer the ultimate gender neutral glue guy. Here's my my first Chocito pepper level spicy take. I think that analytics is a misnomer in sports. We should stop calling it analytics. Down with analytics. I would argue that a modern analytics department is really a research and development consultancy. We probably go through this cycle every couple weeks or so, depending on who's in season, of some old head saying something mean about numbers. I've always believed that analytics was crap, says Charles Barkley. What has analytics ever done to you? Well, maybe a lot of things. There's this popular perception of analytics being a sort of ask and answer model. This is from one of my favorite episodes of a show by Bleacher Report, now ended, called Game of Zones, which, if you're unfamiliar, dramatizes the NBA in the style of Game of Thrones, and everybody lives in Westeros. And so this is the analytics episode, and Daryl Morey, who is another guy I used to work for, when he's at Houston, at the Rockets, and he's explaining to Carmelo Anthony off screen about how the model works. We feed her data and she gives us answers. Ugh. So Carmelo asks, what should be my role on House Rockets? And the model spits out a one-line recommendation that he doesn't like. He crumples it up into a ball and shoots it into a basketball hoop waistband, which is what Chris Paul has just picked up here. And the Mello says, this model is nothing but a hater. Sidebar, this is like inadvertently a very Mello heavy presentation, so take that as you will. But I think that some of the animosity towards analytics is that it can kind of feel like surveillance, that it's just telling you what to do. And I don't think that it's really so much about an infiltration of people who didn't play the game. I think it's because the products that they use to make decisions about players' lives and livelihoods is this walled garden. And there's this perception that analytics isn't accessible, and too often the audience is for other analysts, not for the people that are actually trying to win games. So what can analytics do for you? We've just talked about managing massive amounts of data. We've just talked about creating visualizations that delight and engage, but also need to be treated with caution with a data fluent translator. And my former director of R&D at the Sixers used to say, we're like a startup that doesn't have to worry about making money. And that's true. The money, you're not speaking to investors, but we do have to worry about making money, because it all comes back to making money. But the idea of an analytics department is essentially to increase your win chance, your win shares. We value a win at X number of dollars per game. We value a championship at X number of dollars. And so the value proposition has to be fair. And so to go back to my original definition of analytics, the point is to mitigate bias, to supplement the eye test, and to hopefully work towards making the best possible decisions, developing and implementing the best possible strategies. And that's impossible to do in that ask and answer model of analytics. And so it's not only about having a recommendation or even an opinion, it's about creating a suite of support. And you have to drive your application development around this philosophy. And so rather than being the analytics guys or the numbers, I think that we should consider ourselves as research and development. I want to end on unicorns. Maybe you've heard of some developers being described as unicorns. The unicorn developer who can do it all, the multi-hyphenate Gisele Bündchen of software engineers, the designer, developer, stats model, supermodeler. And maybe you've noticed the beautiful images at the section titles. I hope so, because I'm really proud of them. And you'll have to indulge me here for a minute. I want to talk specifically about the unicorn tapestries. And this is called specifically the Unicorn Hunt. And they're a series of 7 medieval tapestries depicting a unicorn hunt hanging in the Met Cloisters in Upper Manhattan, which you should absolutely go visit if you ever have a chance. These tapestries are considered to be some of the best and most significant works of art surviving from the late Middle Ages. And they depict a group of noblemen on a hunt for the elusive magical unicorn. So on this tapestry on the left, they're depicted as attacking the unicorn because they're trying to get the unicorn horn, which was considered to be able to heal wounds and purify water, even though they're not real. And then on the right, the resurrected unicorn is sitting docilely in an enclosed pen. And I particularly like the Met's description. He, the unicorn, is tethered to a tree and constrained by a fence, but the chain is not secure and the fence is low enough to leap over. The unicorn could escape if he wished. Clearly, however, his confinement is a happy one. The red stains on his flank do not appear to be blood, as there are no visible wounds like those in the hunting series. Rather, they represent pomegranate juice from the bursting pomegranates above, which are laden with medieval symbolism. And that's just, it reminds me of this quote from Brett Brown, the former head coach of the Philadelphia 76ers. We are star hunting, or we are star developing. That's how you win a championship. And if you're thinking about some difficult organizational decisions, some roster decisions, we had drafted Mikal Bridges in the first round, our hometown kid from Villanova and the son even of a Sixers employee. And then we traded him immediately on draft night for the rights to Zaire Smith and a future first-round pick. Zaire, unfortunately, is no longer in the league. Mikal is a starter. But it reminds me of the expectations for technical staff. Everybody wants a unicorn. We want that, on average, one developer or engineer per team, and we want them to do and be everything. We want them to be a hit. Why is it so hard to hunt for unicorns? And it's because they don't exist. They're mythical creatures. In sports, you work in the passion economy. Part of your compensation is working in sports. You get championship equity, but if you win, you don't IPO. So if it makes no difference to you, perhaps find a more lucrative position slinging code in an industry with more regular hours. And there's a certain amount of sports-specific statistical literacy that is required, either pre-existing or a willingness to acquire. And I suspect this sort of domain knowledge is developed in any other normal job. So if you worked in healthcare insurance, I don't think that it's reasonable to expect that you should be a healthcare insurance as an engineer. But if we considered sports to be a real job, then you should be able to learn the sports part on the job. So my question is it harder to learn how to code from scratch if you're on a team, or is it harder to be a coder who's getting up to speed with a particular sport? Chicken or the egg? And obviously it depends, right? This problem is really team specific. Basically, do you have an environment where you can grow, and does that environment favor one direction over the other? And it's probably easier to bring someone into baseball analytics, but is just getting comfortable with Python if you already have a database. And so I think in a front office, engineering is probably the furthest away from that core sports domain knowledge, even though you need to know both to be successful. So if you're a scout, you get to do your job by doing more just by watching basketball. But if you're an engineer, you're wearing multiple hats. Like, it's almost like a second job to stay up to date with the current trends, tools, techniques in the computer part of your industry. And I think that the sports industry in general doesn't quite understand how big of an ask that is. So I find myself often telling people who want to break into sports analytics to build projects in public with sports data. And I say this as someone who's had an arguably fine career in sports for several years, and I did not have a sports-specific portfolio. I wish I didn't have to do this. And I wonder if framing a large body of passion project work, i.e. something that you do for free, as an unspoken requirement for getting a job in sports analytics is suboptimal, both for hiring teams and for recruiting talented individuals. Which is not to say that it's not helpful advice. It's really good advice because teams very rarely hire for these positions, and a public profile is absolutely one of the ways to get attention from teams. And I think a lot of people pick up programming and analytics because they're passionate about a particular sport and they have questions about that sport and not the other way around. So this is nothing against putting up sports analytics work online, like a Twitter or your own blog, if that's your thing. Like, you should absolutely do that. But I think that the type of analytics work that is popular in public on social media isn't as in high demand for teams for a number of reasons, like publicly available data is inherently less rich than what teams have, and it's very expensive to acquire that data, and also it's really boring to read a tweet about Docker files. I also think that it's important to remember that the people who are filtering out the first line of resumes typically don't have a technical background. You're not applying to a technical company, you're applying to a sports team. But if the popular paradigm of what doing sports analytics is very specific and narrow, then you're going to end up with that laundry list of requirements for that full stack data scientist, software engineer, designer, probably below market rate from HR, because teams don't understand that they need distinct technical roles and you've only got budget for one, the unicorn. Oh, I've got one more slide and it's a dog. And it's hard for teams to understand that growth. We can over-index on sports domain knowledge or background at the expense of finding some really great people. And I sincerely believe that this internal bias disadvantages groups who aren't already well represented in a front office. So I can't end this talk on such a dire note. So here's a picture of my dog. His name is Victor. And I think that the takeaway from today should be this. There's a lot of opportunity here to make a big impact, and there's some really hard problems coming down the pipeline. Basketball, for one, is certainly not solved. And if you enjoy doing computer bloops and it sounds like it would be something fun for you, might I suggest you become a software developer? So thank you, and I would love to hear some questions.
Thank you. Thank you, Tegan. That was awesome. We're going to take some questions now. I believe we have microphones to pass. If you have, just raise your hand.
Questions?
Oh, I forgot to make my joke. I had a joke about my dog. He's dressed up as a porcelain net. Yes, thank you for laughing.
Stop sharing. I know that there's not nearly enough funding in the world of women's basketball, but do you know, is there like a role or a position in like the WNBA for software development or data analysis?
The Minnesota Lynx are currently hiring for a data engineer, and I could not be more still. I don't know why.
That's all.
No?
Yes.
Okay. So the Minnesota Lynx are hiring for a data engineer currently. And I think this is really because they're taking seriously the need for building out a data infrastructure in the correct way. The problem with the WNBA, they don't subscribe to Hawkeye data sources and the connects on data from the commission. That was really just a and I think that it's going to be something that
Oh, okay, yeah. So if I'm trying to see maybe if I can stack the speakers.
but then you see
Oh,
the Las Vegas
okay, these are the speakers.
Becky $1 million. There isn't a cap on front office staff, and so I think that it will start to happen.
Grid.
It is already happening.
Yeah.
The Mystics also are supported by data engineering staff, headed up by the lovely Kathy Evans, my dear friend. So yes, but not enough.
I'm gonna start from the left over here.
You mentioned the bubble at one point. I was wondering if there was something about your job or the preparation for games that you had to change based on the fact that it was in the bubble. And then also was there a specific statistic or trend that was kind of unique to the bubble and varied greatly from the other seasons?
Yeah, let me think about the best way to answer this, because the bubble, I'm on the Philadelphia 76ers. And the way that we prepared for the bubble, like after getting over like a severe bout of depression, it was really difficult because and we played such a high cadence of games, and so our seas for other teams was different, and we also didn't have the film from the season because it was several months later. And I think one of the really interesting effects of the bubble was the lack of crowd, and so shooting became much more efficient. And oh, I can't say this name, I'll get in trouble. But there are certain examples of players that had really like breakout bubbles, and the question is like, is that an evolution? Is that something that's going to happen? Are we going to be dropping 50-point pieces on the regular now, or is that just something that happens because we're in this magical kingdom? But yeah, shooting in a pure environment, and that's not necessarily surprising because you do see that in practice as well.
Can you turn on the mic? Is it on? Turn on the mic. Switch it on.
As like undergrads or grad students, we see these jobs going around on Twitter for like internships that are those full stack data science analyst positions with the full on like 20 requirements that no like single degree is going to have. Do we just like apply for these? Like what's, if we have like public facing work, do we just apply and just know that we don't have?
Yeah, you got to shoot your shot, man. You should do it. That's all a wish list, and yes, like you are gonna have to do that. But on the flip side, you do get exposed to literally the entire stack, the entire data stack, and so it's difficult, but it also is a great a proving ground of like what do you find interesting. And in my background, academically and before I came to the Nets was much more back-end focused, but now I find a lot of joy working at closer to the top of the stack and working in product development and design. And so I think that like working in sports should be like a real job. I wish that our internships paid more like a FANG level internship, but alas, they do not. But it has to be an environment where like you can actually learn skills and not be expected to be just an underpaid full-time employee. So do it, go for it.
I'm sorry, due to time, I think we should move on. We are set up for the next panel discussion.
But
Thank you.
yeah, thank you. Thank you, everyone.